Welcome back to the fourth module of the course Knowledge and Data. My name is Stefan Schlobach. I'm going to start this module with a short recap of module 3 and everything we've seen before. So this course is about knowledge and data, and what did we see until now? So the main message of the first week was that in order to really make use of data, we need formal knowledge, or we need knowledge about it in the first place. And if we want to automate the process a little bit or make it easier, then we also need formal knowledge. And once we have knowledge and formal knowledge, we can turn data into useful information, which becomes actionable and so forth. As part of the first week, we also saw that knowledge graphs are a useful formalism to combine data and knowledge, as they are not so much restricted to a schema, and they make the meaning of the attributes explicit and are thus more flexible, particularly when you want to share data sets, in particular when you want to share them on the web. And when you want to share data on the web, RDF has been shown to be a very useful representation formalism and data model. And this is the one that we introduced and discussed quite some time, and with which you played around with in the exercises, and which we hope you are familiar right now with. Once you have built a data set in RDF, you want to get access to it, and you can do this in a programmatic way, as you've done in some of the exercises, but you can also do it with Sparkle, which allows you to write rather complex combinations get rather complex combinations of data out of your data sets. And you can do it, for example, also via HTTP. So you can access every Sparkle, every RDF data set that's available on the web, which makes this a very powerful general mechanism. We finally looked at RDFS, which is the RDF schema language, in which you can model the metadata of the data, and also information about the domain, such as given domain and ranges. And this was the exercise that you worked on last week, so I'm sure you're all familiar with that. But what already has become clear, I think, also from some of the questions in Piazza, is that RDF is not sufficiently rich and expressive. So there are some examples where you wanted to say things and you realized that this is not possible to say in RDFS. And there will be more examples of this later in this module in the beginning. And we'll show how this is solved in OWL. Because OWL is the web ontology language that has also been standardized by the W3 Web Consortium, and which is now the de facto standard for people who want to model ontologies and make them usable on the web. And this allows you to have more expressive class restrictions, property restrictions. You can say things about equality or inequality of classes and instances. You can talk about disjointness of two classes. You can give number restrictions. So a dog is something that needs 4 legs, for example, and so forth. And this is rather complex, so you need to practice this, and it will be part of the exercise that you will practice it. And there is a whole discipline around modeling properly, which is called ontology engineering, and there will also be a lecture on this in this module. So good luck.